Okay, so I'm going to talk to you a little bit about adding and subtracting and then multiplying polynomials here that you're going to be doing this week. First of all, just to make sure you understand, a polynomial just means that you have either a number or you have a variable or you have numbers and variables together. So it could be the number 2, or it could be 2x, or it could be 2x squared. And then you could have a polynomial means you could have one term, so you just have that, or you could have two terms, 2x squared plus 4, and so on. I'll kind of show you that as I move through this. But to add or subtract polynomials, I basically have it here. You're combining like terms. So like terms have the same variable raised to the same power. And if the terms are the same, then what you're really doing is you're just adding or subtracting their numerical coefficients. So if you look at some of these examples I have, they're in parentheses. It's just saying here's a polynomial and here's a polynomial. Add them together. This polynomial has two terms. One term is 2x, the other term is 4. And then this polynomial has two terms. One is 3x and the other one's a negative 5. There's an addition sign here in between, so it's saying we're just going to add like terms. So I'm taking 2x plus 3x. They both have an x to the first power. So I add their coefficients. This is called a numerical coefficient. So 2 plus 3 is 5. And then I just bring down the variable they have in common. And then for a negative 5, they don't have variables with them, so those are called constants. And they are like terms, they're the same, and so I add them together. And so that's my answer. On this one, I'm adding together these two polynomials. This polynomial has 3 terms, and this polynomial has 3 terms. And notice that they're not in any particular order, so I just need to make sure I have like terms. So x squared for here, and here's an x squared. So I kind of wrote it separately. So I'm going to combine 5x squared and a negative 7x squared, because there's a minus in front of that, so it's a negative. And then 5 plus a negative 7 is negative 2, and I just carry down that x squared. They had the x squared in common, that's why I could add the coefficient. And then this is an x to the first, and this is an x to the first. So I just rewrote it for you so you can see what I'm combining. And 2 plus a negative 3 is a negative 1, and they have an x. And then my constants. Okay. This example down here, you'll see again it's addition, but there's more than one variable in here. But again, as long as they have the same variables raised to the same power, then they are like terms. So here's an x squared y, and then here's an x squared y. And so I wrote those separate for you. So a negative 2 plus 4 is a positive 2, and I just carry down the variable or variables they had in common. And then there was an xy here, and there's an xy here, so I wrote it separate so you could see I'm adding a negative 4 plus a positive 2 to give me a negative 2. And I wrote down the variable that they had in common. And then there was nothing to combine with this negative y squared, so you would just bring it straight down into your answer. You couldn't combine it with anything. So there's my final answer. Okay? So again, I have a note over here for you. Pay attention to the variable or variables and their exponents. In other words, you just want to make sure that you're adding the coefficients of terms that are the same. Same variable or variables raised to the same exact power. Okay, to subtract polynomials, the only thing you have to remember to do is we're going to change subtraction to addition in the sign of the next number. So this originally is a subtraction. I'm subtracting this polynomial and this polynomial. Now notice I just put them in parentheses to kind of separate that. But the first thing I'm going to do is rewrite them. Now notice when I rewrite them, I don't use the parentheses because I don't really need them. But I'm going to change this subtraction to addition, and then I have to change the sign of every term in the second polynomial. So that's what you see that I did here. And then I just showed you how I combined the like terms. So x cubed, there were 2 terms with that. There was only 1x squared and 1x. And then I had these constants that were the same. So I'm just writing them out so you could see which like terms I am actually combining here. And then I did the same with this one. So you can kind of walk through it yourself and see that I just changed subtraction to addition. I circled it just so you could see I did that. But then you have to change the sign of all the terms that are in that polynomial you are subtracting. Then you can go ahead and combine like terms, which is what I show you in this step. Okay? All right, so then we have multiplying polynomials. So multiplying polynomials, this you'll be doing in the next worksheet. But when you're multiplying polynomials, remember your rules of exponents, because what you're going to do is you're going to multiply the coefficients. They don't have to be like terms to multiply. you're going to multiply coefficients, and then to multiply bases that are the same, remember you add exponents. That's what you did last week. So one example would be if you had a polynomial here, which is just one term, so a monomial, times this polynomial, I'm going to distribute this 3x on the outside to every term that's on the inside. So I kind of wrote it for you separate so you could see. So I'm multiplying the coefficients, 3 times 4, and then x times x squared. Well, when I multiply bases that are the same, remember from last week, that means I add their exponents. Okay, then I'm going to distribute 3x to a negative 2x. So I'm multiplying 3 times negative 2, and then x times x would be x to the 1 plus 1. I add their exponents. And then I have 3x times 9, so I multiply the coefficients, 3 times 9, but there's only that 1x. And that's what you can see here in this final answer. Okay, in example 2, this is if you have polynomials. So this is 2 terms and this is 2 terms. So they call them binomials because it's 2 terms here and 2 terms here. Well, there's something special we can do. It's called FOIL. It's just an organized way of distributing. So F means first term times first term. That's what I showed you here. O are outside, so I'm multiplying these outside terms, x times 4, so I wrote that. I are the inside terms, so negative 7 times x, and I wrote that for you here. And then L means the last term in each, so I have a negative 7 times 4. And so I just multiply those together, and I wrote those out, and then I combine like terms if I have them, which I do here, I circle them, and this is what I ended up with. Okay? In example 3, I talk about distributing again, but what's different is this time, instead of having just the one term I distributed up here, I have this 2 term that I'm distributing to this trinomial here, because there's 3 terms. So what I'm going to do, and I wrote it down here for you, distribute x, which is the first term in this polynomial, to all the terms that are in the second parentheses. So I took x and I multiplied it to 3x squared. And I got this. Then I multiplied x times 2x. And then I multiplied x times negative 9. Then what I'm going to do is take negative 4, because I got to take the sign with it, and distribute it to all the terms in the second parentheses. So negative 4 times 3x squared, that's what gives me this. Negative 4 times 2x, and negative 4 times 9. Then I combine any like terms I have. So I showed you I underlined these are like terms, so I combined them. And then negative 9x and negative 8x, those are like terms. And you can see what my final answer is. The last example here, example 4, just be careful when you see this exponent on the outside. You can't use your rules of exponents because that only applies if you have multiplication and division inside, not when you have addition or subtraction inside. So what this means is take the base, 2x minus 7, and multiply it to itself twice. So I just rewrote this problem so it looks like this, and then I followed the FOIL, which I did up here. And I showed you here, this is the first term in each, the outside terms, the inside terms, and the last terms of each. I'm just showing you here what I'm multiplying. This is what it multiplies to. And then I combine my like terms that happen to be here, and that's how I ended up with that answer. So just remember, with adding or subtracting polynomials, make sure that you have terms that are the same. You can only add or subtract the coefficients if the variable or variables and their exponents are exactly the same. Nothing happens to them when you add or subtract. But when you're multiplying polynomials, the rules are different. You multiply the coefficients, and then you multiply the bases. And the way we do that is what you learned last week. If the bases are the same, you add their exponents. Okay? So good luck on the worksheets for this week. And if you have any questions, just make sure you let me know. Email me. All right, great. Have a good day.